Hey, this is Coffee Compiler Club. We're here to talk about compilers and language runtimes and garbage collection and GC and funny new languages that people are working on left and right, anything else that seems to fall in the same category. And you're all being videoed and you'll be up on YouTube within, an hour or two. And that's, I don't have any set agenda, and that's my normal starting spiel. And I'll talk overloads till Simon comes back, because Simon's long overdue. We've pushed him off like 3 times or something. Oh, there he is. You want to start, or you want me to go for like 5 minutes and then go, Simon?
No, start.
Yeah, so I've been working on AA. We're going overloads. I went a long time trying to do overloads as well. I'm using for ad hoc polymorphism. Is what my intended goal was, to let primitives be a series of overloaded functions to do type conversions for like int float widening and the like. And that was the goal for them. I sort of, I guess at Alan's prompting, went down a path of making them a little more generic and a little more generic. So they weren't just for functions, but I could do sort of anything type-wise with them. And I decided they looked a whole lot like an actual struct with fields. So it's actually a reified thing. It's not only types. It's not like a typing system thing per se, which means that you basically have I want to say an untagged or tagged C, so it's type tagged C union, where the tag is known by the types alone. So there's no explicit tag field. Here's Matt now. So anyhow, what that turns into was I basically pass around a struct now. So this is not anybody's classic overloads, but it works for my issue, and it seems to be useful in general. I pass around a struct where I pick the field from the struct for you. That's the type inference. So at the point of use, you ask for a field from a struct. And this part I could not make happen automatically. I have to have some sort of syntactic hint that says you want a field out of the struct, or else I get all kinds of ambiguous cases. And I can demonstrate various ambiguous things if I don't ask for a field directly. So you ask for field, I'll name the field for you. You don't have to tell me what field you put down. In the context of doing it for primitives, already primitives have some syntactic sugar, which takes the inline binary operator, unary operator, primitive, whatever, and mangles the name a little bit, does a field lookup, which right now will return you another struct, and he'll do a second field lookup out and for the second label based on the types. So like if I ask for an add, I'll get basically a classic C++ vtable set of pointers to functions, and then I'll do a second load out of that known from the types alone, that you're doing int plus int or int plus float or whatever, which means you can pass the plus operator around as a normal like function-like thing in all contexts. And you can have an array with mixed int and multiply and divide and every other binary operator, and pass that along and pick one at random and just apply it between 2 elements. And I'll get the right actual primitive operator done independently, because I'll be able to infer types. If you want to use overloads yourself, all you have to do is use a field syntax for doing a load where you leave the field name blank, and I'll just tell you what field you're getting. But any struct I can do this with. So I have some easy test cases that kind of show you what it looks like. Let me look up overload. You guys saw these like a week ago, 2 weeks ago, and then I got distracted with
It sounds to me like logic programming, like you leave a fresh variable in there and it gets magically filled in with the thing that it's figured out for you and whatnot.
It's a limited set of things you fill out here. So here's not core. This is core AA, which is actually like a straight up lambda calculus syntax, where I pass you like, I'm calling this color red as a pair. That's my struct.
I'm not seeing anything either
I
in
put in
the
the Google
document.
Docs. Which Google Docs do you have? We had a Google Docs link fail.
I clicked the first link that was posted in chat here.
Oh, if you click the link, go scroll down below where Simon's typing.
Oh, sorry. Yeah, okay.
Okay, yeah, I'm down a ways. Okay, so I have decrement as subtract, is empty as a string only operator. So the dot underscore, so red dot underscore and red dot underscore appears twice. The dot underscore is my current syntax for saying this is the field. This is a field reference. You get to pick which one, or I'm going to pick which one for you. Here's a more interesting one. It's going to be cut and paste. I'll have to clean it up a bit. No, that would be not a cut and paste. How about this? Yes. All right, let me clean this guy up a little bit here. I'll use some primitives I don't have in the core piece because it just doesn't have primitives. Here's a better way to do this here. Oh, I don't get.
Are the slashes before the quotes because this code used to be inside of a string?
Yes, we'll get rid of those. So this is the example I want. This one says color is a function which takes a hex and a name and returns me a struct, which I'm going to call as a color thing. It's just a pair of values. And I make it a red and a blue, and I get let's put hex in here, whatever you want to have for the hexadecimal RBG coloring and a string. And then I can make a lighter guy. So this was supposed to be, oh, this is not the good one. Hang on, I'm going to make a little change here. Yeah, this is a better one. And yeah, here's the should be. Let me go clean that out and just do it directly. Ooh, oh, there it goes. So all I'm doing here is saying, with this cat again. And what is this? Is probably leftover. So this is like color is a function which makes a color given a hexagon string. I make some colors. Light is a function which takes a color and makes a lighter version of it by subtracting some from the hex value and appending the word light to the string name. So it makes light red and light blue. And then I just use them both. So light's a polymorphic function which takes a color argument. And I infer all the types of all this, including the underscores appropriately are picking the string or the int.
So dot underscore, what is meant to represent?
That is a field lookup, but you don't get to name. I'll pick the field for you. You don't need to write the field name. I'm going to pick the name for you.
Is it positional or based on the inferred type?
It's based on the inferred type.
So this will produce issues if you have tuples with more than one string or one int.
That's correct. It'll come out and say it's ambiguous.
And then you have to specify a type.
And then you have
a name.
Yeah.
All right.
He'll claim ambiguous if he can't get a unique pick out of it. So for like the plus operator here, if I say A plus B and you don't know whether A or B or floats or ints or strict, God damn it, Google, put that. And this becomes, that's the operator. Use a binary op. A and B are unknown here in this context. So this is going to be a struct here of three things. It's actually going to be a tuple, and main AA, which has a slightly different syntax. I can just put commas and things in here. And I'll put in here a dollar for a prim here. Int, float, int, float, and string. So the definition of primitive add And then this is syntactic sugar for a dot dot underscore on B. Let's see. Look, I got a bunch of people here. No, here's Jim. Let me admit Jim here.
And maybe we can share screen.
Why do you need the dereference for dot underscore?
I'm getting too wide here. And here's Max. Okay, so ask your question again.
I get why it turns into a dot look up the add B, but why do you need the second dot underscore?
Because a
why
dot,
is there a second dereference?
Yeah, the a dot plus under loads a struct of 5 elements. Now I have 5 elements. They are int plus int is a primitive, int plus float, blah, 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 string plus string. And I need to pick which one. So I'm going to load again one of them, but I don't know which one. So I'm going to infer the field. Then I'm going to use it as if it's a function and pass a second argument B in. Based on the types of A and B, I will be able to infer which of the elements of plus I'm referring to, which field I'm loading for the second go around. Basically, the first A dot under plus under more or less loads me a V table. And then the second dot under says, pick an element from the V table.
But it carries all of the overloads with itself, basically.
But which carries? A is, whatever A is, will have a class-like structure behind it that the plus field comes from, because the plus operator field itself is a bunch of static final constants. So they'll get moved out of A and into A's prototype. So the implementation for A can be a bare int. The typing for A includes, it has a plus field that has only got, constants in it, so it's moved off to the class. So the implementation takes no space, but the typing system says you're doing a load to get the.
Yes, yeah, but the overload here would be represented by a struct, as I understood it.
Yeah, the overload is represented by a struct. Here I have a 5-element tuple, but tuples and structs.
It will carry all of the overloads with this struct. So in order to try to, it will carry all its context in order to resolve at later point what
yes, the type for the plus operator will include all of the different functions it could be referred to.
So we try it from the left to right, or how it would try to resolve it?
No, the typing system demands that there is exactly one that is correctly typable, and all the others are an error to type error otherwise.
So it will continue at the first it was able to resolve, but it
will demand that exactly one resolves and the other 4 are type errors.
Oh, yeah. So if there are more than ones, then it will declare ambiguous.
It will declare ambiguous if there's more than one. This is not an ordering. This is, there must only be one. There is no ambiguity here, or you get an ambiguity error.
Okay.
Cool. So when you call a dot underscore plus underscore, does that give you the full table structure, or is it pruned? So for instance, there are no floats in your example of color above.
Right. It will give me the full table, because A will be whatever plus operators I've shoved onto the A thing, because the parser doesn't know shit about what your types are. He sees a binary plus, he turns that in via syntactic sugar to load the under plus under field, whatever that turns into. In this context, if A is an int or a float or a string, in any of those situations, I'll load up some kind of a structure that looks like what you got there with that 5 tuple. It'll vary. If you're an int, there won't be any leading float fields. If you're a string, you won't have the leading int fields or whatever, because the first element we typed according to the dude. Then also the parser, again, without any clue, will just inject the second load, which is pick the element out of there. And that'll be the definition of how I do operators. So the parser does I'm a dumb parser. I recognize that you've got an operator. I'll insert loading the operator field, loading a resolving second field afterwards. And then he'll walk away from the problem. And the typing system will come along and say, the first guy had better turn into a struct-like thing. The first load turns into a struct-like thing because there's a second load after it. The second load is unnamed, so I need to be able to resolve it based on its contents, the type of A and the type of B. And he'll do a resolution from there that just says there can be only one that is correct, the others must be in error.
Yeah, okay. And the dot underscore parenthesis B is actually a function that's resolving a field out of the argument.
The dot underscore is a field load. It gives me a function.
But normally so C dot underscore, it's clear. It's a field load of something out of C.
Yes.
But then in the next code block there with the A plus B, you've got A dot plus underscore plus underscore dot underscore, and then the argument is B. So it seems like it's reversed there. Like the dot underscore is actually resolving out of its argument.
Let me add some clarity. This is main AA, and main AA has standard C-like function call syntax.
Is there
it actually ambiguously has both versions, whereas core AA is a simple type lambda calculus syntax. So in core AA, all function calls have an open paren, then the function, then arguments, and a closed paren, as in a standard lambda calculus. Main AA has a C-like syntax. There is a function, then there are parens and arguments. So the order of the function and the parens is reversed between core and main. And I'm showing two different syntaxes. So that's part of the confusion here.
Would someone mind emailing that to me, please?
I'm sorry?
Would someone mind emailing me the doc?
The doc is in the chat. The link was incorrect. The text of the link is correct. I'm sorry, yes, and the link itself is incorrect. That was the confusion with the doc today. Sorry.
It's okay. Oh, well, all right, I'll try and get it. I can't get into the chat right now.
Oh, you can't get into the chat. Well, I sent you an email. The text of the email is correct. The link is incorrect. You'll see they're different if you hover.
Oh. So copy got it.
Yeah, I cut and paste, and it didn't change the hyperlink. It just changed the text, and it's like, geez. Fine.
This is not a group of people who knows how to computer.
Yeah,
exactly. I do not know how to computer. Do not ask me to computer. I build small little gizmos. That's it.
Yes. So Derek, does that clear up the confusion about the function calls?
I guess so.
Okay.
It's kind of funny because I have the feeling that A has this property, which is the plus operator.
Yeah. And
the plus operator has a property resolution, which we're saying basically plus operator has to resolve something out of B. I guess that's what it's doing.
It's resolving out of A using the type of B. So the plus operator has the property that it's going to take two loads. He's going to load from A table of functions. He's going to load from the table of functions. He's going to expect then the second load returns him a function. Okay, now he's got it.
So this is about resolving the plus. It's not about I thought this was applying plus to B, and then you needed to resolve a field in B.
No. B is not having anything done. Only the type of B is interesting here. I'm not looking in the guts of B in any way.
I see. Okay.
somewhere in there, the type of B and the type of A have to be two arguments to a function that's listed in the list of functions for the plus operator. Yeah, and then somebody down below was trying to ask a question about using type of. Basically, yes, the resolution for the dot underscore is based on the type of A and the type of B. The type of A should be fixed in the set of functions, so it's really based on the type of B. And you can have more arguments here can be than just one. You can have a 3 or 4 argument operator.
Can we share a screen so the?
Yeah, sure. Sorry. You mean share the docs, or you want to have your screen shared?
No, your screen.
Let me share the docs. This just so they're on the video. Yeah, for future video people, here's the docs we've been talking about. Which mostly the top section is core type lambda calculus, which has one kind of function call. And the second stanza is the main AA, which has a C-like function call syntax. So they're reversed. So mostly what came out of all this was I couldn't make the dot underscore itself be inferred directly. I got too many ambiguous cases. I couldn't sort them out. And I tried a couple places of adding some syntax to clean up the ambiguity, and I kept finding more cases where I couldn't clean it up well. And then it occurred to me that for the case of doing the primitives, is the only reason I wanted to do overloads in the first place is that the parser is just going to insert the damn second load anyhow, and that I didn't need to clean up the ambiguity in any other way. And so after I backed off from that, it turned out to be pretty easy. So I still have to do the resolution of the field, and that has to be fully polymorphic. And so there's some games going on there that are unusual in the Hindley-Milner algorithm style, but they're not out of control anymore, and there's no more ambiguity. So once I figured that piece out, it took me under a week to get to here, and then all my overload tests are passing, and I got one other random non-overloady thing that came as a side effect of something else I was doing. I need to go sort out, and then I'm done in theory. I was hoping to say I was doing done today on core AA and go back to the main code base, but I think I'll be done by this weekend, go back to the main code base.
So what's the next step? What are you going to do next?
Take what I've done here and go push it through main AA. So main AA I have a couple hundred tests in main AA that have worked well up till I got to the point where I needed more polymorphism. And I had a different strategy for doing primitive construction or primitive calling. And then that had its limitations, and then it got me down this path of doing this overload thing. So right now, the main AA code base, like 6 months or a year ago, the main AA code base would run like 90 out of 100 tests, and then the remaining tests all needed some form of real polymorphism, and they showed it up, and it was like, obviously I had just kind of quit screwing around, go be polymorphic again. I went back and forth as of like a month and a half ago. Main AA ran up to the first real primitives, and I stared at them with my new polymorphic understanding of things and decided, hey, I could do overloads, and then this make the primitives a lot more conceptually cleaner. And then that turned into a month and a half of overloads with 2 weeks gone to go to Italy, which was a lot of fun. And then, so now, yeah, I'm going to go back to main AA and get the overloads on the primitives. That'll only get me through the first 10 or 20 test cases, well, 30 test cases. I guess probably have 200 or 300 test cases in main AA. Once those clean out, I'll probably roll through the test cases in main AA pretty rapidly, knock on wood here, particle board, and see if I can get myself to, like, as far as I know, I'm done with type theory. And then I'll, get test cases pushed through main AA to where they all type properly. And, I don't know, I don't want to say anything about where I'm going to be when that's done. And then I don't want to add any more features to the language until I get an implementation. So the next thing after that is get some sort of executable execution strategy, but that's probably still a couple months away. A couple being, 6, damn it.
Yeah, I pulled AA the other day and tried to run it, but it didn't do much.
Yeah, what you do, because it's broken, because the main is broken, is you go to the test HM test case suite, which is the core pieces, and you run them, and you'll see that they mostly work.
I see.
But the main guy runs up until, like, the last time I started moving polymorphic things into the main guy, and I got up to doing something wild and crazy with primitives and realized that I needed to quit doing my stupid hack and go do something official. So I went and, screwed around with overloads. That's my official thing.
Yeah. I downloaded it. I built it. It built. I opened up the REPL. REPL started.
Yeah.
I thought, I'll do a 1, and I hit enter. It gave me an error.
Yeah, right. Exactly. Yeah. Sorry. Yeah, the REPL at one time did something. Now it immediately calls the parser, which calls whatever and immediately chokes on something. I haven't turned the REPL on in like 6 months either. So
yeah.
I'm assuming it's toast here. Somebody anonymously is trying to figure out.
It didn't affect my project. I was just curious where things were at.
Yeah, right. The answer is things are pretty broken. Theory-wise, I think I'm closing in. I think I'm actually done on what I want out of the theory, and then I have some execution of the theory, and then I'm back to main AA and make that go on the main syntax. And then that, I guess there's some. I have some thinking on arrays, but they probably don't need any theory hacks. I think the arrays will just float in as pretty easily off of non-theory hacks. And then I'll be, sort of done with featureitis on AA. I'm way past featureitis on AA. I need to quit. It's just like, until you use a language in anger, you don't know what you got right or wrong, And I've never used it in anger, so I can't say that it's good or it's bad.
Do you ever try sort of pseudo coding against the language in design? Like, I've been doing a lot of that for my thing.
Several times. And then, there's a point where it's just sort of, not to be rude, but mental masturbation because you're not actually doing anything. You can't run anything. Let me find somewhere in here. I have a really nice...
APL existed on chalkboards for years before anyone wrote a compiler.
Oh, there you go. Here is a very early version of hashtable, which I quit the share. So let me go restart the share. And then I haven't looked at it in a while, so I don't know if I've screwed up something on it or there's some changes made. So here is an implementation of a hash table. It's really poor. So hash table is defined to be a function which produces a struct. So it's a no-arg function returns a struct. So the use of this, would you just say hash table with open close parens? It's like in Java, you would say new hash table. You get a new hash table. Okay. Because hash table is a function that when called with no arguments gives you a struct, which is the table. There is a table, which is the hash table fixed at 7. There's no resizing this tiny table. The array syntax is bracket 7 bracket that says, make me a table of 7 elements and infer the type of the table. There is a search function which takes a list and a key, and it's gonna walk a linked list. So this is a bucketed table, and I'm gonna pick which of the buckets with a mod, and then I have a list of buckets. And this is just a version of walk the list looking for the matching guy on the list. And so sorry, go ahead.
I am just wondering, the types of the hash table are inferred because inside of get and put, you are using the tab field, and probably that uses
Hang on, I gotta take this.
All right.
Yeah, I said hello first.
Which does beg the question, if you want it to be more generic, if I want a table of animals and the first thing I put in is a dog and it takes everything for a dog.
True.
In this style, I believe the key and the value are polymorphic and the get and the put types are not linked together.
Yes, and I'm on a call right now. I'm on a conference call, and I need to not take this call any longer.
That's true. I'm wondering what it does if you're using different types, if you're having a hash table constructed,
Scala,
doing a get call, doing a put call, and the types in those get and put calls don't match up.
You busy doing what here?
Yeah, we're asking if the key here in the get correspond to a key here in the put, because as it stands right now, or at least my understanding, that these doesn't need to be the same type. So
well, the key has to support an equals test with another key.
No. Let's say if you have a type key here, then both the get and the put would know that the key type should agree on both sides. Here, is it possible to pass a different type?
See, I highlighted key.eq of key. So it's possible to pass in a different type as long as they have a common super type, which their equal call supports. So your key has to support an EQ, which takes another key of the same type. And then, like if I have a hash table that hashes on objects, and you pass in a number here and a string there, as long as the equals call accepts numbers and keys uniformly and declares equals if they're equals, then it's the same as a Java hash table using object as a key. Yeah.
When you bind to the variable, like this hash table, do you have to declare the types at that use site, or?
This is entirely polymorphic, so you can add a type annotation, and if you do not, I'll infer one, which will be based on the sort of the most general types that appear. So if you pass in sort of widely varying values for key, you'll get a hash table would infer a very widely varying type for the key type.
Which is almost would be resolved to some structural type. That would
a structural type that takes a .eq and a .hash. Somebody's asking a question, compile time error. No, I would declare a hash table as taking an object. He's going to have to wrap the 23.45 in a wrapper as a separate thing, and then he'll do you put a string in an object table, and you do a lookup on a float and a capital D double from Java, from a capital S string from Java. You get a hash table, it's object to whatever your object in it right now.
So this would be equivalent to a Java object for the key.
Right. If you don't put an annotation on the type, he'll just keep widening the key type to match whatever keys you put in.
How would we specify the type explicitly at the call side?
You put a colon. So, and say it's going to be a table. This is a good point here.
Type parameterization.
Yeah, it's right. I don't have the right syntax convenient here. Hash table is a function which returns me. It has a get and a put, and the get and the put themselves are functions which take a key and yada yada. So this becomes a long description of hash table, and I want to hand you a shorter type. Like I would put in a named type for the hash table first that had a shortcut to expressing the whole thing. Because what really hash table is, it's a function which returns you a struct. The struct has get and put, and you ignore implementation like search and tab. And get and put have a key value which shares a common type name. And I have type variables, so you can do that. There's a way to demand get and put take the same key, and it's the same key you put on the hash table. I don't have a shortcut way to write that. So I can go write it the longhand way, but it's really ugly to write it longhand. I'll do something here longhand and then decide that I'm gonna update your thing here. It has a get, which is a field, which is type. Let's see, this is the type part. And the get is a function from a K to a V, and has a put, which is a function of K comma V into nothing, because it's the same table. But I have to have something here. Get probably returns you the prior V. it'll be something like this. And I'll infer that K and V are type variables because of their place inside of a type description as free type variables.
But if I wanted to specify the instantiated type to make sure that I can't do mistakes, how would this look?
Yeah, so you would replace, well, right here, as I'm saying, I don't have a good shortcut. So right here, you would say, you know, string for, oops, shit. So I'm looking at your cursor, not my cursor. Replace V with string.
Okay.
Just
this is not the way you want to do it.
A thought here that maybe this wouldn't work with all types, but with something like hash table, you could actually say that the get function is kind of representative of the type of the whole thing. And I wonder if there'd be a way of specifying that in the hash table definition. So you can say basically, if you provide a type hint,
there is a way to do it.
It's the type hint for the get function, and then you infer all the rest from there. And then you'd have this K arrow V as your type.
Yeah, and I wouldn't use the get function as that way, but I would definitely add a type name
variable.
Like I can add a type name here.
Oh, okay.
Let me see if I get it here. Yeah, the hash table is which is equals colon. So this is a type description, and then it's going to give me, it's going to be this. And it's actually a function which returns that, and that now I have a K and a V here.
So is there a way to disambiguate between type variables and type arguments?
Yeah, so I don't right now have a syntax. I know I need it. It's coming. I know it's just a syntactic change that says that when I define hash table, it's basically, it's my cursor, which is your cursor again. So as a type description, I don't need the KV there, but when you go apply hash table down here, I would say hash table is, table is defined to be a hash table. So you want to put a type syntax on table. So table is a variable which has something, and I'm going to say, I made a hash table, and what I got out of it is a thing here, which is a hash table. Hang on, I'm getting that. And this would be string from the end. So this would be, table is make a hash table. This gives me a value of type hash table of string to int. I wrote it down below there. And so the first thing, this is okay. And for the second guy, this is an error. And like I said, this was a very old cut on me trying to code in anger, and I didn't have the typing annotations worked out for polymorphic type variables in the annotations, or generics, if you will. I don't necessarily like the generic syntax that I've given. In fact, I've had some discussion about that a while ago. I ran a Twitter poll, and I want the spaces probably. So that would be this version if I can get the ambiguity worked out. But it says that whatever table is, and in fact, I can put that on the other side. Here's on the result side. You'd probably actually rather have it over here. So table is typed to be a hash table, taking a string and an int. And here I'm filling it with a hash table. But I just call the hash table function and get a hash table. So that makes tables a type as a normal variable whose type is hash table from string to int.
A general question regarding the struct syntax. What defines whether you get a new struct every time you call hash, or whether you get the same struct? How would the syntax of the definition
so when
change?
I use the word hash table to the right of the equal sign where you have a question mark, okay, here, so this will be make a new struct. This is a constructor call. The hash table open close brain is a constructor call. Whereas when you say table.put or table.get, those are using a prior thing. But if I say hash table with open close paren, that's a constructor call. It makes a new. It's just the same syntax as if I had the word new in front and you're in the lane of Java, except that I don't actually have the word
And
new.
how would the definition above look like if you just had one hash table?
Like, oh, you don't want to make a new one every time? You want to have a static global. Okay, so if I wanted to make a static global hash table, or change a thing that said I would define hash table is equal to open. Oh geez, it's Twitterizing. Click that. Jesus, what? Open. Unfortunately, see @ triggers all kinds of things. So I don't wrap it in this makes a struct, not a function which makes a struct.
All right. So the second pair of curly braces.
Yep.
All right.
The first hash table, let's call this hash table 2. The first hash table is a function which returns a struct. The second one is just the struct.
That would be pretty easy to miss it though.
Well, if you're defining a hash table as a librarian, you probably, got it figured out. If you're Joe user and you want to make a hash-like thing that's private in exactly one and only one, and you have custom gets and puts, yeah, you just skip the open curlies. Instead of making a function which makes one, you just make it. Always in AA, I like the thought of wrapping things in curlies to make them a function. I can thunk anything by wrapping it in curlies.
How do you know that there are only 2 type parameters at the call site?
At the new site?
Yeah. Or how does the class, or how does it say that it only takes 2 and not 3? So suppose I put like string int.
Okay.
Who would fail?
Hash table, okay, you have to be careful here. This hash table is in the namespace of type variables because it comes after a colon. So the bottom hash table has string and int that's highlighted in red on my screen right now.
Yep.
Is in the type namespace of types. So going up to the top here, up here, I have a namespace hash table. It has 2 arguments. That's how it knows it has 2.
I didn't see that part. Yeah, thanks.
Yeah, no problem. Yes.
It's probably like Haskell, where you have to look at the definition side for the signature.
So I have a namespace for types and a namespace for values, and they're different things. So you have to figure out which one you're talking about. And always the namespace for types is used following a colon, and otherwise it's never used. So yeah, okay, fine.
So how would the type below look like if you had more type constructors there? If you had, say, let's think of something. If you hadn't a string but option of string, because at some point you have to decide on which brackets or parentheses you pick to disambiguate things, right?
So when you said that, say again where, like, make a new example below where you're trying to do. Are you asking for I have multiple different constructors, or are you asking I just want to have option of string? Oh,
exactly.
Yeah. Okay. So option of string I'm doing a different way here, but that doesn't. Let me fix option of string, but that's not the issue. That yeah, list of int. So option is done this way, but list is going to have a parens.
All right.
In the type system. So I don't have the ambiguity worked out for the space version of things. Like Java uses angle brackets.
Yeah, I mean that's the thing I dislike about the Haskell approach with using spaces, that you're not really saving any brackets or parentheses there, but you're delaying your use of brackets or parentheses for the second level of nesting. So with all the others,
I did this poll on Twitter for asking who likes what kind of types. I just cut and pasted in 250 odd votes. everyone loves like angle brackets because too many Java people piled in. But number two was spacing, which has this ambiguity issue with exactly where do you put the string of type variables. You know, you're going back to your original example and getting rid of my question mark. It's totally legit here. Option, string, list, and it's ambiguous as all hell, right? How do you break it up? And so if you're using spaces, if you're using rounds, I'm using parens here to group type variables as a parens grouping, not for rounded type variables for your polymorphic types. Oh, I see. Somebody's saying for spacing you can add.
Yeah, that's
angles,
what
squares.
that's what
I
I'm saying.
Squares or rounds
You're
as well.
saying you're saying like you're not using any brackets, but you're using a space. Is like it's not the whole story. You're still using some kind of parenthesis. You just delayed its requirement.
Yes.
One
and then
further
under
nesting.
that model, angles being the most popular, you do angles. But I find like the Java nested angle brackets, when I get my types nested a little bit deep with the angle brackets, really hard to read. Like here's some angle brackets thing. I just don't like those. I'm totally with you here that using spaces just moves you off one layer. You still have to choose now grouping. And which grouping do you use? So squares or regx? What? Rexx? Did you mean regx? That's Theodore. Are you typing something?
No, it's not.
It's not you. Who's Anonymous Wolverine? Oh, okay. Oh, well, no. How do you say list of ints? I see question, plus, and star, which isn't a thing here. I'm using question mark for option because that has specifically a meaning of I meant this or no.
But I like the idea. I mean, I think it's completely new. It's something we haven't seen before, that you indicate how much additional types come after some type while instantiating it. I think that's interesting.
I do not.
So if I did it with angle brackets, never space, you get this looking thing, which would be hash table with a bracket and then a set of things. And you can imagine putting commas here if you like. Probably you don't want commas there. I don't like that either. Here, I have two unrelated things, but list itself, list needs this angle brackets. I had this wrong. You needed this version of using angle brackets.
Scala all the way. Yeah.
Which is what Scala's take on it.
So, and then again, what the possibility of type lambdas of not specifying fully this type?
Scala is using squares according to my question from the internet, which is what I had done with. Yeah, so here you said somebody put my int, made it an underscore. That would be only possible if I was inferring it was a list of whatevers, and I don't know what. It's polymorphic.
That would be a type lambda to a hash table of string and a list with something in it.
Yeah, I would put a type variable and not an underscore, even if it was not bound anywhere else.
How do you disambiguate it that you want?
Because A is not in anybody's namespace. But then you're
that would be hard.
Yourself in the foot if you make dangerous. An A type.
Yeah. Somebody defines a class A and all the code changes meaning.
Right.
So this would be.
I haven't sorted that one out either.
In Scala lingo, this would be a type lambda, a type that itself accepts a type in order to fully saturate the hash table type.
Yes, right. And so this is you naming the set of type variables in a scope for the hash table string type, which is fine. It just adds another layer. And I could, I could go there. I mean, I have like function types. I can do type variable types for naming things as a namespace option. It's not ambiguous. It's just like but tons of extra syntax.
This would be the function at the type level.
Not. Hang on. So this is the version. I'm exactly doing what you're doing here. So I'm going to remove your comment because I just took exactly the comment. Okay. So here is the trick here is that because it's got polymorphic types for the list, you have to use that. But if you don't have any polymorphic types, you don't need the A arrow. So here's a table that you just said is that, you know, it's a string question mark to
this is like for all A.
Yeah.
This is like for all A is the hash table from stir option to list of A.
Yeah, right.
It's universal quantification.
And there's another one that says, oh, quit that auto capitalization, man. Oh, it's still gonna auto capitalize me.
I guess the problem here is that if you're using a shorthand that is not really clear where how far the A travels out.
Well, it doesn't go past the edge of the type description. That one has this syntax has a hard, is not ambiguous in any way.
Anything that is from the left of the arrow is what is bound inside.
Yes, right. So when I would parse that, I would see you've got an A, I don't know what it is yet. I'm going to hunt until I find either the arrow or something else that clearly indicates the end of a list of identifiers. As soon as I get something, as soon as I get the arrow, I know I'm doing a type parse, same as I do for my function parse. As soon as I get something else like the square, like the second piece I wrote, you have a square bracket. I would say hash table might be a list of identifiers. Next token, please. Next token is a square bracket. Not a list of identifiers. Go back, reparse. Hash table is known to be straight up a type variable name, the name I'm defining. And now I'm parsing standard types and I have no free variables.
Yeah.
So it's not ambiguous in any way.
This relies on the syntactic disambiguation.
Yeah, and you've buried one internally instead of externally, which maybe that works as well. That's not ambiguous either.
So
what I'm worried about is that these are different, and I think you can build obscure use cases where one is right or the other is right.
Well, I wasn't going to say the third example of table there was correct. I'm looking at it thinking, oh, maybe. Why is that different from my first table : A arrow? Oh, Cameron's here. Geez, I'm not paying any attention. Hey, Cameron, sorry, I wasn't paying attention. We're hard into it. And the link is wrong. Cameron, it's probably you texting me, telling me you can't get in. Yes, it's still going, Cameron. I hope you're in now.
Hey guys.
Yeah, the link is wrong. The text of the link is correct. The link itself is wrong. Find it in the chat. Sorry, I cut and paste it, changed the text, not the underlying link. So everyone's on the wrong Google Docs. We're down near the bottom, the middle of the Google Docs. We went through AA overloads, and now we're doing type syntax. What is a good type syntax with generics? How do you specify generics or type syntax? Okay, so Simon, you were saying something about what's the difference between the first table with A arrow and then the third table with hash table, blah, 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 A arrow list. What's the difference in the type here?
Yeah, exactly. So if you write it down, regardless of whether the syntax is valid or not, if you invent some kind of shorthand, like for instance Scala has with the underscore or question mark, I don't even remember anymore, then the problem becomes relevant, because then you have to decide how the sugaring looks like. It's a bit like with the value lambdas of Scala. If you use an underscore in a lambda, it's sometimes unintuitive how it's desugared or how many layers are traversed to the outside. I mean,
yeah, I don't know Scala enough to know this example. I'm looking at the syntax that was just written there for the third one. This is different hash table type question mark. And it seems to me that this would be the same type as the first guy.
The first guy, this is a type lambda, which asks to give me an A. I will give you a fully parameterized hash table with a list of what you put here. The second one designates that it's the argument, second argument of the hash table is a function that itself takes an A and returns a list on A, would be equivalent to a new list on every invocation with some argument.
What is all this typing buying over just the structural typing?
It's so you can make hash table polymorphic. Like in the first table is, well, I'm giving it a type. The first table is typed as, oh no, the first table I would.
Aaron has a point. There is some overlap with, you can leave it just a structural type. You can select some of the fields. Here in Scala lingo, this would equivalent to a nominal type. The type has to be fully known, but you have the option to not fully specify what we are dealing with here.
Well, I'd have to see the description here.
And to answer, at least from my point of question of Aaron, the types here to constrain the hash table to not too quickly go to an object Java equivalent to something that can be anything. Here would be, at least my opinion, bad, because if you do not constrain the type, the Hindemilner will be too eager to make the type here any, because it's how it fits with the usage of the hash table.
Well, it'd be whatever the usage of the table is. Whereas if you're right.
So Dan, what's the syntax supposed to be?
Well, I'm sorting out now. I think is a bug in everything that's going around here, in that the type I wrote up front here was really intended to say hash table takes two type arguments, but table himself has to be an instance and it has to be given a type straight up. Like table is made here as a constructor, and the first table here, it's a constructor not to a list of A, it's a specific one. Which one is it? It's not a list of A, it's a list of some named type.
Do I have audio here?
Yes, you do.
Awesome. Okay. I posted a Kotlin equivalence that I work in a lot based on type aliases. It's down 2 boxes from this one.
Maybe we should do a Rosetta Stone and put these 1, 2, 3, AA prototypal and Scala and Kotlin one after another.
I just started using that website.
So Kotlin gives you type aliases with the JVM and with LLVM. So it's convenient. And the assumption that I'm using with these type aliases is that there is an array and possibly a mutable list to take advantage of beyond the interface. But that's basically one interface to do, composition. So your interpretation of HM, does it have a compositional type alias that, boils down to whatever, more HM?
I'm not sure what you mean by compositional type alias. Near as I can tell, I have a fairly...
Would that be a type def, Jim?
Yeah, this is what is C++ type?
Type def.
Type def.
TYPEDEF. Yeah, type def.
Okay, yeah, but that's
a little bit of a while.
That's an inline type description, as opposed to
it gives a nominal type to any other type, right? That's all it does.
It replaces the type name in the text with the body of the type, expanding it inline. Doesn't work for cyclic types, but otherwise it just flattens the types out.
Right, but it's not a macro.
But it doesn't.
It's essentially a type macro. Like semantically, if you were to look for the same thing in if you were just doing a dumbass C++ or C type parser, C language, and you didn't know how to handle the types, it would be correct every time you saw the name of the type def to just inline the body in that context. It is effectively a macro which expands completely to base terms at every point.
Is it treated as different type or like a Haskell new type?
No. C++ type alias? No. No, I'm talking about
generic
type alias.
I think it shows up in RTTI though, so it's not erased like a macro is. Okay, so Jim, if you can explain though what the sorry, I didn't mean to interrupt you from describing what you were trying to accomplish.
Well, we were staring at different ways to write megamorphic types, generic types in Scala and AA, and when does it become ambiguous, and what are the limitations of it?
Well, my question is, like, if I were to use macros instead of a formal type alias or type def, would I be, littering the namespace with duplicates? Or, is it already basically done? By attempting to litter the namespace, you're going to recognize isomorphism and put it all back together.
So, okay. So if you expand type defs in line everywhere, it does not change the namespace at all. So there's no littering of the namespace. And they're isomorphic in the end because they're all just the fully expanded base types. Like standard structural recursion will tell that they're all, recursive equality check will tell these types are all equivalent. Now, if you want to backwards that and say, and here I had a name, but it's equivalent to this other thing, but I know that there's a name here, then you can track that. And as far as I know, C does not, and I don't know if C++ does.
I think C++ does, but just for RTTI. But
I think you made an allowances for imports to rename, which is the same thing, but it's at the import wherever that's declared.
Right, but it does imply that there is a nominal type on the other side of the boundary, so that the name has not been erased.
Right, and I definitely keep the name around. I don't do the expansion trick. Like I looked at Elm, which gets its type straight from Haskell, which comes around and says, definitely he fully expands them, just like I said, to ground terms, and then types it from there.
Yeah, I think Jim's point is pretty important though. I mean, it's one of the reasons that we have a reified type def is so that the name is visible across a module boundary, which is quite handy when you're producing a consumer of an API.
Right, so I'm going to say in the land of C, the across the compilation boundary, the ground terms will match and C will let it slide by. I don't know if C++ will.
Okay.
Like
but
two different
C
things.
does that by header file, right?
Yeah, it's a header file which has type defs, but the type defs are as if they're fully expanded into ground terms. And he will claim that you are type correct if you have a nominative type that expands versus one that you have handwritten out fully expanded. He'll claim they're the same and walk away.
Yeah, and the challenge for that, the trade-off for that is that the recompilation of the library, so a new version of the library, means you have to recompile the client.
No.
So
if you change the types in the library, then you have to recompile the client.
Sorry,
yes.
That's what I meant. Yes.
Oh yeah.
Yes. So and so that's the benefit of say nominative typing and say Java is that there's a much clearer set of rules about.
If you change the types of a named type in some library and you use that type in some other unrelated compilation unit, he'll have to recompile as well in case you've invented new type errors.
You can certainly do things that would break it, but what I'm saying, I can see, for example, the size of is if it changes, you can have a pretty tragic error pretty quickly. if you're trying to jam 16 byte, 32 bytes into a 16 byte struct because you compiled with a previous size of or something.
Size of. Size of.
Just a simple example.
Yeah, size of changes the implementation as opposed to just the types.
Yeah, and I didn't mean that you were saying size of. What I meant is you allocate an array, or it's inside a structure or something like that. So the benefit that Java has is that I can have lots of different changes on the other side of a library without necessarily forcing a recompile.
So size of objects, ints and floats and the like don't change across the boundary. But if you, in terms of compilation unit, but from the JVM's point of view, the verifier will look at your two types, verify they're the same, and the JIT may produce different code in the client because the actual implementation of the type has changed. But he passes the verifier. So the exposed visible portion of the API is the same between the client and the library. The library makes some changes changes the type. If expose the library, just add some extra functions in the type. Then the client would do a verifier check, confirm that the types are compatible, and wouldn't change his typing except the presence of extra fields that he's not using. Yeah, I think there is something there where he's okay. Where size of is a little weirder. Size of says.
Right. I meant when I said size of, I just meant that there's a potential for things to be hard coded in by the compiler based on what was read in the header on the other side of that module boundary.
So it does seem like a good idea for doing some assertions when you load a DLL to make sure things haven't changed.
Right, and it's simply a trade-off. Like there's nothing wrong with forcing recompilation of the universe every time a change is made, but it should be a.
Well, somebody has to verify whenever you have a linking process. You have two unrelated compilation units, and you want to say one calls the other. Somebody has to verify across, and the Java that's the verifier, right?
Right.
So that process is always going to happen.
And in C, it's the CPU. Right.
It's the linker.
I mean, maybe sometimes in C, it's just you didn't realize you had an ABI fail and everything blows up.
Yeah, the linker does a poor job of it and lets a lot of shit fly by. But it's the linker who's confirming that everything that the caller wanted and the callee had offered were compatible. But he does, like I said, he does a shitty job of that, and shit could fly by, and then you break. I'm trying to decide if we are figured out. I'm trying to figure out where Jim's comment about scala
definitely had more catastrophic errors linking DLLs than I have adding jars to the class.
Oh yeah. The DLL linker does like I said, he does that's his goal, but he does a bad job of it.
Symbol munging is not part of the Kotlin language model. The type aliases are purely at the compiler side in the IR, whatever IR is chosen. But the question remains, like series is it's an array abstraction or a vector, which specifies a generic type.
We were arguing a whole lot about hash tables and keys and values just above. Can you restate your comment as a hash table with a key value as opposed to an array?
Okay, sure. So the array is the key value, the Java entry list that exists inside a map. So you got a series that is a vector of key value pairs.
That's not what I'm trying to get at here. I'm looking for the Kotlin syntax for a classic hash table, which has a key and a value, supports a get and a put.
This is a
not building a linked list up using indexes for ints to go get a value out per se, other than a hash table which takes ints to a value is kind of like an array.
So if you look, mapish is one of the join pairs. The first, the A type is a key function that returns a value, which is enough of abstraction to give you a hash table where that function does, hashing.
Okay, so join. So the third line here, type alias mapish KV says that it's the same. It's an interface called join. It has a K in parens, which I guess is an argument list, returning a V. That's your get call.
This should be abstracted entirely by the structural types. It doesn't.
I'm missing, right. And then series is what you're saying is give me put returns me a new series, which is a list of K's and V's or something.
Mm-hmm.
Yeah, the second is the specification of a series of pairs.
Right. Okay.
Of KV.
So I don't want to write my hash tables in this syntax. We had this discussion earlier about really having bad types for describing my hash table in AA at the moment. So what is the convenient, easy syntax to give me a hash table that converts strings to ints? Or strings to nodes. I mean, I'm just making two shit up here. I mean, I want two shit types. Give me a type description for a hash table from strings to nodes.
Mapish. Sorry. Okay. I'm typing in the screen share, of course.
Yeah. You have to go to the actual docs to do that.
Let me find the right tab.
For me, it's the same, so I can cheat on it.
All right.
That looks better.
So mapish. You said string to int?
No, I'm using not an int just to get away from ints.
Okay. Any or star.
No, not any, because that's also overloaded. Node is like, no, not any. Yeah, node, like a concrete type.
Animal.
Person, animal, great, animal.
And then you would instantiate the interface somewhere else, and you would have to go through the hundreds of compiler errors to say I don't have a function for this, I don't have a function for this. But you would like C# has mix-ins, so does Kotlin. So you can
right. I'm not talking mix-ins here. I'm looking at. So what you wrote is mapish string animal, and you instantiated. And so I assume I get a variable, I get a value back, which is of type mapish. Then and then now, okay, now you're describing how to define mapish's interface contents. This is right. And that would be my example above you about hash table, where I declared a hash table. And the syntax for describing a hash table from strings to animals and all that. I mean, I actually have a hash table implementation above.
As I see it in this tape, I think this is equivalent to a type variable. It's type renaming. It doesn't provide.
Which one is equivalent to
the type alias? Type alias should be, but to me, it's equivalent to a type variable. It doesn't. It's just for a renaming scheme to get the same thing. It's not type on its own.
That's what I'm believing. Like at this point, it looks to me like a C type def. I can just do inline expansion of type aliases, and it'll boil it down to the ground terms, which is even series and join will disappear, and I'll have a bunch of A's and B's and arrows for function calls. And that would
be all of that, but it's more polymorphic than defining interface after interface after interface, inheriting from each other, and having the graph limitation.
Okay. Yeah. Well, we're looking at Hindley-Milner style things, so we don't have to do the. I mean, there's no piles and piles of interfaces floating around. Operator fun mapish get. Yeah. I like my syntax for defining the thing a little nicer, but fine. That looks reasonable. And then you're using angle brackets. Somebody asks, what is wrong with Java syntax for angle brackets? I find deeply nested angle brackets, such as you see 3 closed angle brackets in a row in Jim's example here, difficult to read as they get thicker and thicker. And for whatever reason, I tried square brackets above, which is like the Scala answer and Python answer, and I like that a little better.
Another answer may be like type aliases to like reduce the nesting depth. That's kind of cheating.
Yeah. You pile on type aliases to reduce the nesting depth, no problem. I'm just saying you can also still have, like even in this example where he says mapish, he still has 3 closed angle brackets.
Mm-hmm.
And I just find that many like difficult to read now. So, maybe 3 square angle brackets are no better, but I'm thinking it looks a little better. I'm going to scroll the Google Docs windows up. And here I've highlighted some of our versions of things where a hash table takes a nillable string and a list and, returns a list of int. And I have square brackets, and I'm finding that easier to read as a type description. And then the A arrow or fat arrow is to what you do with, you want nested polymorphic type variables, and how do you define them? What's the scoping? And I tried scoping with and without the arrows, and I'll probably end up having to do an arrow to be unambiguous. I scroll here, there's no help up here. Fine.
An interesting
Actually, I can control
point.
here. I can do arrows here. This would be the arrow thing happens here. Here's a fat arrow version of the same type for hash table. It takes a K and a V and has a get, which is a function from K to V, and a put, which is a function from KV to V. And actually, I don't put commas here.
Can you annotate the K and V to be structural? To have...
KV here are free variables. So they're actually free. If you want to, if you then use this type, so that's hash table as the type name. To use the hash table, you supply a K and a V. The KV you supply can have more structure to them. I mean, that's exactly down here where we're saying, table is a variable which has a hash table which takes 2 type arguments, which a list, event, and a string question mark, and I make a new hash table and yada yada. Whereas this one I highlighted here, I am unclear what the type of table is, because it's a hash table straight up. What's it returning me? It's a list of A, but every time I use table, it's a concrete instance. So it has to be fully typed here, in my opinion, and it returns me a list. There's another way of saying it's a list where I don't care what it is, or a list of object. So I don't, in this syntax here, I would get rid of this and say, oh, it's a list of any as a type name, and that's my list of object.
So the question is, can you emulate it without the type lambda, just with the structural type inside here? I think
that's right. So basically, A is a free variable in the definition of table, a concrete value, which I can just replace that with Java-Lang object, which is, for me, that's all. I said any, but it's actually all.
Yeah, that would be, yeah. Okay, let's leave it here.
Yeah, right. And then I go down to just, I was saying, as a Rosetta Stone, it'd be nice to see Jim's version of thing next to the others, so you get a feel for how it would be to use either one or the other in context. Like mapish is so I want to say table. I make some personal table I'm going to do things with. It's a mapish. Do I have to say new here? I don't know if I probably don't have to say new. I want a new mapish here of strings to animals.
We only have the interface that on the screen. We don't have the impl.
Yeah, but I'm calling the interface. Oh, I see. I need an actual. So somewhere in the universe, I have a hash table implements mapish. And some contents to it. And then down here, I would say, oh, I need a hash table. And it's going to be a mapish, and mapish takes 2 arguments. So string and animal it is. And you're saying it's val, which is fine. You get free capitalization whether you like it or not. So here's a val table, if maybe that's a little easier to read.
Okay, it's singleton.
Yeah, I don't know. Right, and maybe I want to have a singleton type, which is like a global variable or whatever. Yeah, so you've typed object. Okay, so you've given singleton the type plain old object, and it's actually further typed. Why is it
the
object?
mapish.
No. So if that's
Singleton is the
Kotlin,
name.
object means singleton. Yeah.
Object is the same as
static global.
Static
Oh,
global.
okay, fine. I see.
Yeah.
Yeah.
Top
Okay.
level,
So
no class.
now you've defined a static variable. You have to fill it in with an initial value, for which I'm claiming, it's hashtable, which implements mapish.
IntelliJ is going to, give me a lot of prompts and whatever, fill in the blanks.
Yeah, I'm not worried about
to get there.
Who's filling in. I'm looking at what is the compiler see here. It's something like this, and now I know the thing called singleton is typed as interface mapish, which takes string and animal and does what whatever the interface supports, which includes some sort of get and put like thing.
Yes.
Okay. Okay, that makes sense. So right. So my original goal was to say, how does this look in other languages, to see if there's a better answer, and you supplied me the Kotlin version. And then under the hood, mapish himself is a join and nested with a series, and join has a get-like behavior, and series has a put-like behavior.
Series is a vector. We don't see a impl with mutability.
Yeah, how do you know that series is a vector? Where do you get the vector notion from here?
Vector is an int length followed by a function that takes an int and gives you back a value.
So the pair of int and function from int to value is known to be a vector.
Yes. So
I can imagine many things
immutable
that are typed as int and function from int to value, and they would not behave like any kind of vector ever. Why
I use it to wrap lists and arrays, and they are difficult to mutate without writing an impl that makes it mutable.
Yeah, I'm not talking about the mutable impl. I'm talking about how do you jump from a pair of int and int to value to vector?
Wait, you have a lambda that takes an int and gives you a value.
I don't see a lambda here.
That's Java and lambda syntax there. Well,
it's in a type context, so it's not a lambda syntax. You're in Java angle brackets. You're a type.
Oh, yeah, Kotlin uses Java lambda.
The function type. He's saying there's a type there.
Yeah. So now I have a join in the line you're on. Join has two type variables after it, two concrete types.
Legal. That might be legal. I'm not sure.
One of them is int. One is a function from int to value. You said vector. I supply you with a concrete implementation that takes the int and ignores it, takes the int from the function, ignores it, and value fires the missiles. This is not any vector-like behavior that I know of.
You have to supply a function that takes an int and gives you the value from that int.
Yes, and I just named one. I ignore your int and return you a constant value, fire the missiles.
Oh, anytime you like, of course.
I think secretly this abstracts over the apply method, be it on the vector, on the list, or so you can use it in whatever context you like.
Exactly.
So the here is the index.
Yeah, exactly what I'm saying here is there's been a mental jump from this pair of types to vector.
Mm-hmm.
Where did that come from? Where does this mental jump come from? I can certainly define a set of things, takes these pairs of types, and they don't behave like any vector.
You can
accessor.
Yeah, I'm not saying that you can treat this like a vector, but you can treat it like a non-vector. What forces the join to behave like a vector?
That's why it's a type alias. Of course you can. This is my revenge on Java. It is just, my own OCD style. But nonetheless, it raises the question of whether or not your HM provides this in all cases.
Well, I'm trying to figure out what it is you're providing. So what I heard you
series interface mapish, will it end up the same as a type alias in the long run? It sounds like yes.
So Jim, is what you've done here kind of decomposed a hash table into different discrete pieces that can be plugged together randomly?
Yeah, that's working pretty good for me so far.
Yeah, I mean, I see he's got. I understand that you have a thing which is the type of I have two behaviors, a get and a put like behavior if I want them. But you keep saying vector, and I keep thinking I can make a vector with this type. I can make other things.
He's got an internal array of entries or something.
Yeah, you're talking about this is an implementation that has a vector-like behavior. I can give you another behavior that is not vector-like using the same description. So this is not a description of a vector. This is a description of a thing that takes an int and a function from int to v and does whatever the fuck it wants with the ints and the v's. And it's not necessarily any vector.
Yeah, but it's sufficient.
I can't argue with you.
Okay, fine. That's okay, because you kept saying vector, and I was like, you automatically inferred vector? How do you infer vector? But you can say, I'm going to treat it like a vector, and I'll have implementations which behave vector-like.
You can pass all collections that have an apply method for Scala, for example. All methods have implicitly a function-like behavior from an index to whatever a collection implements. So here you can pass a vector, a list, or whatever it has implemented.
I understand that the description here is broader than vector of all vector types. So certainly all vectors can be described this way. Also, other things can be described this way that ain't no vector. And that's what I was sorting out. I kept hearing the word vector. This is not a one-to-one mapping to a vector description. This is a super type over what vectors are.
Correct. It abstracts too much. It doesn't have to be a vector.
It doesn't force me to write a vector. But a vector would have this type.
Yeah.
Okay. I'm okay now.
It's got a name of series. So if I wrote pair, I would collide with standard load. If I wrote vector, I would collide with Java. So I have to take a couple liberties here and there.
Okay. So you're some of the things you're doing are just renaming to dodge these standard libs, which is fine, by the way. I totally get that.
Type alias totally give you this freedom to rename in order to.
I don't know.
So, this is provably more polymorphic than if this was three interfaces. And I would have to write the same AB function getters over and over and over for each one versus, just leverage the lambda specification by generics. That's what I meant by composable.
Okay. So the type for hash table without that I remove it here? No, up here. The type for hash table is this. I'll cut and paste it down below. So part of my.
So Jim, just so I make sure to understand what you're saying, this allows you to build your own hash tables on the fly out of pieces parts.
Yeah, if you really want to do that with a big giant impl class, yes, you could.
So the hash table
or out of those pieces, right?
Yeah.
Supply it a vector, supply that.
It would look like really line noise in Java. In Kotlin, you can do more scope friendly declaration. But, this is just a straw man to say, we have this mapish interface that shows you how you could get a key from, get a value from a key. And store pairs of key value for your convenience. And you could keep composing curious recursive template pattern with this one interface to get everything. As big as you like. Not that I recommend it.
So once you're done with all of this, what would you describe as kind of the takeaway benefits of having composed it in this manner?
Initially, my idea was that you know, the fewer number of classes in the JVM, the cleaner it would run, the quicker it would inline. But you know, I think over the years, I don't believe that is the case explicitly.
There is a thing about interfaces in the land of Java that they're difficult to inline in a general way. Singleton implementations of interfaces, the implementation functions inline nicely. The normal behavior is I can't tell that you have a single implementation of an interface. So instead of inlining, you get a inline cache call, which hopefully, if you're only calling with a single interface, that's great. Otherwise, you get interface calls. And we've had people on here complaining about the speed of interface calls. But yeah, if you get generic interface calls because you have multiple implementations of your mapish, you kind of suck for performance.
And bimorphic is very different than megamorphic.
Yes, the compiler these days will do a handful of hot guys, and then he'll give it up and go megamorphic. And the megamorphic's ugly for interfaces. And this hits people like Jython and JRuby and the ilk, where they have alternative call sequences, and their implementations are all look like interfaces. And then there's a lot of implementations. And so the JIT can't puzzle his way through the interfaces, and he ends up doing interface calls all over the place with lots of targets. And that makes you get a linear scan lookup per function call to do the call. Like, he does a bunch of loads to get some table bases, and he walks a table sequentially looking for a hit. It's not very fast, and this rapidly becomes where all your time goes, because every little call gets turned into this horrific table scan. I'm not saying that you're there, but boy, I've talked to people even on this, you know, in Coffee Compiler Club who've totally gotten there.
Okay.
Well, all right. So my main question is, you know, are we going to see this capability in AA with your code freeze happening?
I'm thinking that I have this kind of a thing. I put the word get and put straight in my type. You have operator fun mapish as maybe an implementation. I have a type hash table which supports a get and a put, but implementations of it can be all over the map. Is this the same thing? I can certainly arrange that the get and the put come in staggered parts and you collect them together.
Yeah, the fact that you can pass a structural type releases from all of the boilerplate from.
When you say pass a structural type, you mean K and V can be complicated types? Yeah.
Yeah, you can pass. This to me means anything that has a get and a put.
Yeah. What I didn't show here was under the hood. K supports an equals and a hash call, and that's inferred from the implementation. Well, that's not fair. Okay. The implementation I produced above requires K to support EQ and hash, but you do not have to use that implementation, and it will not force EQ and hash on you. So I'll erase that. If you have a different implementation, it has whatever that implementation needs out of K. Like, you used ints, which directly have an EQ and a hash. But if I use strings and animals, I would have to know something about how I'm doing the comparison on my collection to figure out which string is the correct string. That typically requires something like an equals or EQ or equals as a standard Java equals. You use something supported there to let you tell one string from another.
You bring up a good point that because I do this, I actually have to go and write boilerplate for every single primitive, or the compiler may, nail me when I, get comfortable. So there are, conversions for, string, int, float, double, so forth and so on, Boolean. Even if they don't make sense, it avoids a headache later down the road. That always happens with tuple abstractions in many languages. Java having the primitive divide until whenever they fix that.
Well, there's a giant performance gain for the primitive divide. I am attempting to straddle the same divide in a different way. It's more like the Rust with zero overhead. You have strong types for your ints, but the implementation, by God, has to be a bare int or you're going to suck for performance. And that means you can't do like vtable lookups on ints directly. There has to be something else going on. You can't box them and then do a vtable
I can't
lookup
speak for the Kotlin team, but they do pre-processing stage with a separate IR before they bake in the JVM bytecode. So they do auto boxing to some degree, and then the LLVM output or the JavaScript or whatever are less impacted.
You have to un-autobox is the right thing to do there. Like I have a strong code quality or code performance guarantee in a bunch of places that says I must be able to fully inline and remove the boxing here, or else I'll declare an error. And you can say easy code that's slow, and I'll box you, and you'll be slow. And you don't care because you have small enough things that boxing's okay. But I sometimes do things with billions and trillions, and if I boxed every billions and trillions, I die really quick.
Oh, as a matter of fact, this type alias is faster than a list if you're using an array backing store, because the boxing is very close to the implementation and it goes away. So I have tested that. It's a tiny payoff in the JVM.
Yeah, I'd have to see how it stacks up in a larger thing. But if you can get the auto boxing to go away, that's always like I'm not letting it get in the first place. I always thought auto boxing was a bad idea from the JVM side of things, but I get it, it's convenient. Just mysterious giant performance hit if you get it wrong, and there's no guarantees given by the language that it doesn't go bad on you. So fine.
Okay, can we shift our attention to Simon?
Yeah, actually. Any other final comments here? Before Simon, we've put you off, and now's a good time.
I think it's 12 minutes. I think we should just do it another time.
I had 5 minutes of overloads, and how do we get into that?
No, let's just do it another time. I think that.
Oh, you've removed your stuff. No, it's down here. Here it is. Vastly improved syntax. Oh, manual syntax highlighting. Okay. All right.
We delay too many times for Simon.
Next time, don't even get me started on a AA update. We'll just go straight into Simon stuff.
No, it's fine if we have more interesting things to talk about.
What's the Swiss option? Numeric literal separator. What do the Swiss do? Is this like Swiss, like the people Swiss?
Yeah, exactly. They like the only country on earth that uses the quotes, and only sometimes, but yeah, I call it the Swiss option.
Okay, fine. Well, I saw Swiss option sometime this week in an unrelated context, still around compilers and languages, and I'm trying to remember what it was. Oh, hashes. It was a Swiss table for hashes.
Yeah, I think it's like related to all the cheese named tables.
So Simon, did you have a lexical conflict that pushed you there?
Sorry?
Did you have a lexical conflict where you were trying to use underscore somewhere else?
No, not in just so the core idea was that underscore is really useful in other contexts, and it's called numeric little separator. So I wanted to have a symbol that actually separated parts of numbers and not combine them, because the underscore connects the individual glyphs together, unlike the quote. So yeah,
right,
that's
but when you're
bigger.
doing lexical analysis, you still have the underscore available even if you allow it to be used.
Yeah, sure. I
literal
just
separator.
yeah. I just don't
ambiguous.
want to use it.
Right.
It's not a problem for parsing. It's just like if it's called separator, I want to use the symbol that separates things.
Yeah, well, the reason I'm asking is that old concept of the weirdness or the strangeness budget.
Yeah.
It does seem like a I'm not Swiss, but it does seem like a questionable way of spending the budget. But
yeah, I think it's I think C++ did the same thing as far as I remember.
It ticks? No.
I think
that
would
allow the underscores?
Yes.
Okay.
Yeah, it's a quote. C++ used the quote. I think that's also a very good Wikipedia article.
Somebody, Matt says, why was space character not chosen? Oh, because that's going to be ambiguous, right? Oh, here it is. Here's somebody using a quote. And user defined literals. And here's a complaint. He's got a good link. And then they're showing counterexamples and complaints about it and stuff. Okay, fine. I'm gonna quit looking at it.
Yeah, so
Wikipedia. Click on links while I'm live. I
says,
trust you, Matt. It's all good.
Yeah, so things like Ada, C#, Haskell, Java, OCaml, Perl, Rust, Julia use underscore.
Yeah.
Fortran uses white space. C++, Rebol, and Red use apostrophe, like the quote. So I think there is like some
apostrophe.
Yeah, it took me a while to parse apostrophe.
One argument I really disagree with is the argument against commas, because the argument was made that the European countries use the decimal separators differently, right? But that makes no sense because you already use period as a fractional separator. So you have already locked in that you're not going to use European convention at this point. So I don't see the European countries argument as applicable. I mean, we have been using digital calculators with digits separated by periods, and no one in Europe was complaining that no, we have to switch all of the calculators to commas. That would be silly. So I just find this argument to be silly. I don't see the reason for this at all.
Which argument?
I have another separator in my hand.
Well, the argument was that we shouldn't use 1,000 separators using commas, because European countries use commas to separate fractional parts. But that argument is not applicable anymore. The moment you use periods to separate fractions, which every single programming language to understand does. So,
how do I see myself?
Makes no sense to me.
View. Show self view. Here we go. Let's try again. Here it goes. A Curtis calculator. Oh, never mind. Okay, so it has red and black pins for the decimal separator.
That's right. That's colors.
All right, fine.
That will solve the problem. Make everyone equally happy.
Yes. Fine. This is a 1950s calculator. All right.
So if not Simon, where to go?
Well, we could wind it down. There's no reason we have to have 3-hour meetings every time.
Yeah.
We get Simon a full slot time. That's all good.
We will start with next time.
I have something that will probably be quick. It was in the Google Doc. It was like the different kinds of the different orderings of types. I don't know if we talked about that.
The different, you mean the square bracket versus angle brackets?
No, this is like, it's like at the end of the code blocks, a little bit above Simon's.
Okay, hang on. I'm going to pull up the share screen and you should point me, get the Google Docs where it goes. We're back to share screen. Okay, where are we looking at here?
So down, go down. And then like, it's right at the bottom. that one.
Oh, different places put type decorations.
Yeah.
So when you have curly quote B quote colon 1, is that B?
Oh, that's, I don't know. I mean, usually people have a syntax for like a literal hash table. So that's the usual one. So that's like JavaScript object notation. So.
Okay. So you're declaring a hash table. Hash table A is filled with an initial value is how I would read that in JavaScript. Initial value being B maps to 1.
Right. Right. And so what the question is where you put the hash table type. So like, there's so like you can put it at the beginning, you can put it after the variable name, you can put it before the literal, or you can put it after the literal, basically.
Okay. For AA, if you put it after the variable name, that variable has that type. If you put it after the end of the expression on the right, the expression is known to be that type. You can put it on arguments in a function. You can put it in the return of a function. You can put it on the function itself. So I allow them in sort of all these places.
Right. And so, I mean, I don't know. So the question is, which is, they're different syntaxes basically. And as far as I can tell, they'll all give equivalent results in most cases. So.
Right. And do you care?
So the question is, which syntax do you like for your language?
Right.
So
I marked the two that AA uses.
Yeah.
I don't use the assembler type. And yeah, ecstasy is doing a Java-like thing, and that the type is to the left of the variable, which is the first one up. For C, Rust, Java, ecstasy is also has the type variable to the left here. So Cameron, you can shoot me if I get this wrong, but I claim you belong on that line.
Yeah.
And the difference between Scala and the AA line is simply you've given more type info, but I claim it's after the variable. So
yeah.
I claim that the AA would also fall into the Scala category because, oops.
I think a core difference is whether you can elide parts of the type.
Right.
So you have like a category of languages where if you ascribe a type to a variable, you have to do it fully. And I think AA, you have the flexibility to not specify the full type.
Right. If you don't put a full type, he will take hash table with the most generic types and declare A to have that type. And then he'll further infer, he'll verify that that is a super type of the actual inferred type, which is clearly string to end.
But how would you prevent to not go too far to an object Java?
Well, if you had more, if you put more things in other than strings, you'd get to object.
Mm-hmm.
I would still take an object as a key and do a lookup and say you missed, same as Java does.
Yeah, but that's not type.
You want a type error.
Behavior.
Yeah, if you want the type error that says that you can't pass a key, an object key in, you have to add the annotation that it's a string. Like the fully typed AA version will kick you out if you said, look up this object. And the second AA version would take the object and simply miss in the table.
Okay.
And I think the other place you're missing for interesting is functions. So let's see here. Let's just do an unnamed function here.
Yeah.
And then here's an arg colon type arrow body. We'll call it string here. And that just only does the thing. And then arg arrow body colon int. And you can also do arg arrow body, and it's the entire thing is stirred at int. And I don't know what the other languages do here. This is a AA things. I can also say fun is equal to string arrow int is equal to some arg arrow body and the like. Here's
there's like a C.
Functions have more choices is what I was trying to say, where you put types. Yes, so there's another version where the type leads.
Yeah.
And yes, that's fine. It always leads. Java falls in that category as well, I think. And I can type an expression, so that's just this. The body colon is just typing an expression. It's nothing to do with functions at all. And the fun colon stir arrow int is typing a variable just like I did the hash table above. But in the body of the lambda, what do you do with function arguments? That's different.
So if we have time after this, I have a quick question, just on a sort of thing that I'm thinking about with sea of nodes in terms of dealing with state in certain case. I don't know if we can.
What we got here? You know, it either goes quick or it goes long.
I think it'll be quick.
All right. Well, we got any other weird types? Like, where does Scala land here? And Haskell puts his types on functions in a different place as well. I'm looking up for the Haskell flavor, and I'm coming back in a second here. I thought we did a Haskell flavor way up here, but I don't see it now. All right, never mind, I don't see it. I'm coming back down.
Oh, I mean, Haskell is pretty similar to AA, actually.
Oh, okay. So you have function as a keyword. I don't have function as a keyword. I said fun, but that's just some function. It's not a keyword. It's just some variable name named fun. And then you do, what's the F there? Function, that's your function name. And then arg body. So change F to be, you know.
So that's a variable name, not a function name.
Yes, F is a variable name. Yes, like F, I have F for AA has that's a variable name. And I was trying to come up with a name that didn't look like a keyword, and fun looks like a keyword. Okay, so that's very similar to A. Yeah, you just shuffled around where they went. I was going to ask, okay, where's Scala go? Like, where's Theodore? Is he still on?
Yeah.
Where does Scala do a Scala function call with types? It's that one.
Yeah, I believe it's the second one. You can ascribe. Yeah.
You put a colon after the argument name.
F, yeah. To.
Oh, double arrow. Okay.
I think all languages in the ML or OCaml family have this in common, that if there is a term, you can add a type ascription to it.
Hang on.
Mm-hmm.
It just blew up on me. Where's the damn chat menu? I hit some button on my mouse and it gave me a fresh window replacing the existing one. So I just like lost it. It's like,
for functions, this is the Scala syntax. It's the
okay. Where do you put the body then? So that's the type.
From the body is here, from the left of the right of the arrow.
Oh, I'm sorry. You have a body as you took what Afrin made to it.
So
Yeah,
that's your body.
Okay, fine. You need to open paren, arg, colon, type. You need the parens, body.
Yeah, you need
parens. Okay, fine. Yeah, okay. Yeah. Okay, and you don't have curlies then, but you have like white space ends the body line or something.
You can put it in the curlies.
Curlies or not, according to whether you need a spacer or not.
If it's a simple expression, you can
skip it. Yeah, it'd be like Java lambda, same thing. Okay, all right, I'm done begging for examples.
Yeah, so as far as my arguments, I think, well, so first I think that having it on the variable as opposed to the value is wrong. Because if we're typing the variable, it should have variable in the type name. So
okay, no, wait, back, say that again. If you put it on the variable because I have future updates to the variable that want to be forced to be the same type. So
Right. So you have a mutating operation on the variable that you don't have on the value. And so you the type should reflect that there's a mutating operation. So it should say mutable variable.
Okay. For me, if it's mutable, I change the assignment operator and there's a final mutation and then your final after that. And the variable retains its type through all mutations.
Well, I mean, so you're saying that you don't have types that reflect whether it's mutable. I mean,
that's correct. Instead, it's mutable or not based on its assignment, the last assignment to it.
Okay. So if I have something that's already final and I pass it into a function that wants to mutate it, what's going to happen?
No, if you pass it into a function, you passed a value. You're asking, did I make it the contents mutable as opposed to the variable?
Can I not pass an L value into a function?
You cannot pass an L value. No. I can do a thing which is an L value typed object, but it's a normal value that contains a base thing and an index that's effectively an L value as a tuple pair. And then you can do, you can use it to do puts or gets or whatever. You can make an L value, construct one from base or parts, but there is no, I'm an L value and I'm passing you along. Like in C, you can take the address of a variable, pass it along as an L value, and somebody can assign to the variable. I cannot do that. Unlike Java, variables are local to a function, and in Java, I can reassign them. They're always mutable all the time, unless I put a final word in front of the variable. In AA, I don't have a final keyword. It's the equals or colon equals, and it's not part of the type. The variable has a type, and and it's mutable or not based on, at the point that you gave it a type, what your assignment was at that point. So it's part of the same expression, but it's not in the type.
Thanks, that makes sense.
Okay, so Alan, does that answer your question?
Well, I mean, it doesn't really answer my concern, which is that it's really the value that has the type and not the variable.
Yes. The value has a type. In this case, I want to say the variable has a value of this type. Under all mutations, it retains this type.
Mm-hmm.
So I'm declaring it on the variable, but really what I'm doing is saying every assignment into this variable will have the value that got assigned will have the type.
Mm-hmm.
We have all three.
You have all three. You have all three. What? You have?
Yeah, I know Alan only listed two, but we actually have three. So we have the compile time type. We have the well, maybe it's only two in reality, I guess.
Right.
But we have the realized compile time type if you resolve the type parameters, and we have the runtime type. So you know both the type of the variable and the type of the value.
Oh, I see. But they're both known at typing time. Like in AA, I can have those. Those are both available because on the value I can put a separate type.
Well, we don't necessarily know the type of the value at compilation time or at leak time.
Well, you have it as a runtime type variable, as a runtime RTT.
Right. So when it's executing at that point in time, we know the exact type, of course. But I think what Alan was asking was kind of a flip of that. Of course, you know the runtime type because it's a strongly typed system, right?
Yeah. Right.
But do you know what the type of the variable is? That's kind of what his question was.
And I give it a.
So for type of a variable, here I'll type something in the next block. So if I have I don't know, a list of elements. I don't know, list of. I'll just put T. I hate it, but if I have list of T list equals something.
Yeah, right.
You know, so and list gives me a ref or a var. Yeah, so var. This is a var of list of T, if you will, but so var list. So I can actually ask, what is your referent type? So this gives me a type T.
So this is yeah.
And that's the compile time type.
Gotcha. Gotcha.
So that would be, for example, list of string.
Yeah. Okay. So replace list of string with a list of generic hash table. I'm trying to come up with, oh, list of, gee, maybe you got it already. Hang on.
Right.
Yeah.
And
okay. So you
runtime...
said list of T, but if you actually filled list with a value which happened to be a list of strings and the compiler knows it, then he could come back and say, yes, you are a list of string.
So no, that's type 2 equals so that would be, for example, array of even better string, which, extends string. So that's the runtime type.
Well, what about a list versus array? List is an interface and array is an implementation.
Yeah, for example.
Okay. Somebody says, and you actually used bracket to indicate that list was user type only as an interface list of some Java lang object.
Yeah, maybe I should have just put this just to make it more obvious.
Oh,
so
okay.
List of string equals some foo, and there's some foo somewhere that says, foo says, I'll use a syntax that we don't have, but where I can just return a
list of string. Just put square brackets and some strings. Yeah, exactly. Fine.
Right.
Yeah.
But the type of list is fully known here on the first line. It knows it represents a string.
Well, list is an interface. So he didn't say interface, but list is an interface. And the list interface includes shit like get the first element, get the rest, whatever. It's an interface.
Is array
the implementation of the interface called array.
That's supposed to be something like array list, right?
Yeah. Imagine, right? You called it list in your code. The compiler knows it's an array list.
Yeah, Java. So
if I go here, I'm gonna do another hack on you. Say that your hello is a Python syntax for a Unicode string, and array is not even better string. It's actually Unicode. Something stupid like that.
Yeah, it's a reasonable example, exactly.
Yes, and I have that information available. I haven't worked out the syntax.
But is it really desirable to?
I don't know. But what do you do with type T at runtime that doesn't cause more issues? I want to have that information available. The type T and T2, that's totally great for all kinds of self-reflective behaviors.
Oh, you're talking the name of the type variable?
Yeah, when you say list that actual type, I want to hand you, I like the notion of handing you a capital T type, whatever that's going to be.
Yeah, so actual type is what Java would just call
get class.
Yeah, get class. Sorry, yeah.
You can actually, as far as I'm concerned, you can call get class there and replace actual type with get class.
Right, but we have sorry. So
yeah.
Well, so my question is like, so if you know, if the compiler knows a precise type for the variable, then why do you declare a type at all? Just have the just say you don't specify the type, and then the compiler figures out the type, and that's the type you
right.
That's a reasonable question, but my explanation is that you have to look at the feature within a context of a language, right? So if I'm using JavaScript, I perfectly agree with you, Alan. But in this case, how do I compare? So our comparison, for example, of
hey, bye, Simon.
So in this case, if I have two of these, list one and list two, right? So I have another one, list two. If I say if list equals list two, what am I comparing? I'm not comparing two arrays. I'm comparing two lists. So the contract for equality comes from the compile time type.
Yeah.
Which means I have to know the referent type.
But it's the referent type being what the user wrote the type to be, not what the compiler inferred it to be.
Right. No. And so the idea is silly in most languages, but in the design that we have, it's a fundamental concept.
Yeah.
like in Java, you know, you list one dot equals list two, and it looks up the equals method on the actual class of list one.
You fell into his trap.
Yeah, I mean, we spent a few hours talking about this one before, but if you say assert list equals list two equals list two equals list, Java will randomly assert on that line.
Okay.
Because it's virtual on the left-hand side. Sorry, Java's dot equals because,
dot equals, yeah.
Yeah,
it's virtual on the left-hand side, and the two different dot equals calls do different things.
Right.
Yes.
Right, but that's why you add a unit test or something that the two equals do the same thing. And
no. Okay, what Cameron's saying here is
it's a problem with the implementation that isn't symmetric.
Cameron says we can solve this at typing time by declaring that
I think Java's choices are perfect within the context of Java. Like I'm perfectly happy when I'm using Java with its decisions in this regard. I just starting from a blank piece of paper, I wouldn't get to the same spot.
You can declare a function that's as commutative, and then the compiler gives you the commuted version automatically.
Yeah, that's actually my language. I literally am reading papers on commutative operations.
Well, as soon as you say that equals is commutative, then you have the question of which equals are you calling when you say list dot equals list two, list one equals list two. Are you calling list one's equals or list two's equals? So here I'm totally with Cameron that there's a useful thing going on here.
Well, I mean, the answer is both. You know, you non-deterministically pick one, and then you require a proof that the two are equivalent so that you didn't make the wrong decision.
Okay, so given that the compiler has
usually
no
what I've
chance
seen there is something closer to lock ordering, to say we are going to come up with some way of putting all of the types into a total ordering, and then say whoever is earlier in the total ordering type.
No, Alan said something different, which is entirely not doable. Prove that these two functions for equals are the same, and other than being like textually equal, you'll never prove they're the same.
Well, but Cliff, I actually disagree, because there's 600,000 man years of academic research into Agda and Koch and Idris, and all four users claim that it's perfectly possible.
Yes, fine. Thank you very much.
Did I get that right, Alan?
Yeah, no, it's I mean, I'm reading the papers again just because I got, I think that they've implemented something, and then I read them again and they're like, oh no, actually they implemented a special case that only works like two out of 10 times.
Yeah, exactly.
I mean,
but that's what I was saying about the total ordering.
Like, I don't think they're just blowing smoke. They have to have something that's worthwhile.
I don't think they're blowing smoke either, but I think that there's a more straight, I think Cameron has a more straightforward observation about how you solve this problem.
Okay.
And that simply say the user wrote a name for a type, that's the equals you're using here. That equals internally does whatever it does with this left and right hand side arguments, but you're not making a guess of whatever list two's equals is via virtual call versus list one's virtual call. You're only getting list.string. It's not a virtual call.
Okay. I mean.
So anyway, so the three that we have are we have the compile time type, we have the strong runtime type, fully reified, and we also have, unless it's been masked by injection, we also have the Gene, what's the term for the class that you create from the conception class? The
user written class.
The inception class. The inception, yes. So that's the thing that was nude, if you will. So for example, the type could be, the difference between type and class in theory could be something like, this one might be, immutable person, while the class is just, the thing I nude was person, right?
Right.
This is the thing that was nude. So there's a difference between type and class. So easy way to think about this is that you instantiate a class and you hand it to someone. You're not handing them the class, the object that you're handing them. In theory, it only has a subset of what the class had. So for example, you don't get the protected methods and the private methods. So what you're getting is a public type of that class. But internally, the code is operating against the
full thing.
I would say that the type is the description of the class, because the type doesn't have a runtime instance, only the class does.
See, Mark?
Well, that's the difference, is that we actually have, so type is an object, class is an object, and they both exist as objects at runtime.
So
he's got a class which has been filtered down to what you're allowed to see. He has a class which was nude, which has all the private fields. He's got the class the user wrote. There's this class the user wrote. There's the class the compiler infers, which should be a super type of what the user wrote, or else you would have a type error already. Then there's the class that you're allowed to operate on and believe exists.
I think the compiler would always try to get from more general to more specific in order to provide you the fastest runtime. And you start with the more general one, and you try to figure out the most specific one because it requires it's the fastest runtime it has.
Just in ignoring speed, it's simply an error if you can't infer the type the user wrote.
Okay.
User writes, hey, list of string, and then foo is actually the number 17 or pi, and it's just an error. You can't infer it. Then there's the type that the compiler inferred, which is sharper than list of string because he observes that foo is done with a new quoted unistring. So he says, oh, you're actually an array list of Unicode. And that is, in fact, a list of strings. So that's an okay thing, but the compiler knows a stronger type.
And we don't flow that through. So we don't. I assume that when we get to the actual optimizing compiler producing native code, we'd flow that through to produce optimized code. But at the IR stage of compilation, we don't flow through method boundaries at all. So even though we have enough data looking at this and closing over the type system, we have enough data to know that it's always a certain type because foo is returning a constant. We don't actually know that information until runtime. So our runtime in this sense is the first time we flow information through method boundaries.
Yeah.
Did that make sense?
Yeah, I mean, right. This is what I would call forward flow typing. You need to type annotations on your...
Would it make sense to always start from the most general type and you nail down to a most specific type?
What do you mean?
I mean that whatever you write, the compiler would always infer the most general thing. In this case, from let's say the array example, would always infer the list, and later down, if you can figure out the more specific instance, it will just infer the most specific instance it knows. Otherwise, would default to a list.
Oh yeah. Okay, so that makes three interesting types here. That's a good point. There is, if I'm running Hindley-Milner, there's the most generic type that I could discover for whatever list is.
Yeah.
There's what the user wrote, which has to be a subtype of that. Then there's what you can infer, which is a subtype furthermore from that, not infer, what the compiler would optimize down to is even tighter yet. One would be, I have Jim Northrup's, I have just a generic, I have a get and a put operators only on it. Then there's, I'm a list of string, which the user wrote. Then there's an array list of Unicode, which the compiler knows because he flow types the Unicode through or whatever, the array list through.
Correct. I've always seen that the inference starts from the most general type. It knows to nail down to the most specific types, no matter how it will end.
Right. And I'm doing this forward flow thing the same way. So I get the most general from Hindley Milner, and I get the array list, the most specific, by the forward flow, and I get the user type, and I don't bring them out as separate things.
The user can influence if you try to declare it, can influence what it's talking about. But if it doesn't specify the type, the compiler will choose to slide down to the more specific.
Well, in AA at least, it's a case of the user's type has to be a subtype of the most general type, or it's a type error. And I'll also find the most specific type based on forward flow analysis, which in this case will get me array list. But if I'm generically passing in an unknown thing, then it'll take on the most generic type, and I have no fucking clue what you passed me. Same as your module boundary or your function boundary. I don't know.
The side effect, I believe, from this is if you have to have a runtime representation of the most specific type. In Java's case, is object. It has a runtime representation.
Yes, there's a minimum runtime representation. I'm trying to think of if I have to also carry forward. No, I don't need the user's type to be carried along with the object, I don't believe, because I should be able to type it.
No. I said that Java has the most specific runtime, the most generic type runtime, which is object in the type system. For Scala, it's any, but runtime for the runtime is object. That's what I was trying to say. So in the Cameron case, I don't know how exactly would fit this.
Well, list of string is this in-between type between the most general and the most specific, which is what the user wrote.
So if we take the full example, here is the most specific type. Here on this line, we widen it to its interface, I believe.
Yeah.
So you here specifically ask it to be widened. That's the tricky part.
If you flow across boundaries, he's specifically asking for it to be widened. But maybe if you didn't flow across boundaries and you just had foo, which was externally compiled, you had no clue what it was doing, it returns you whatever it returns you. Like you said, list of string there for foo, but I suppose I look at the module and he says object. Right, and then as soon as then I get a type error because the object can't be assigned a list of string. So foo has to be at least as strong as a list of string eventually. Turns out the implementation is tighter. It's array list of Unicode. If I look at foo's uses in the universe, or lists, the things that list supports, independent of what the user wrote, I would say list has to support an equals lookup. But I see no other things it supports. So the most general type for list is something that has an equals. And then the user said, oh, I have a more sharp thing, list of string, which totally has equals. And right. And then the call at the line you're on right now is using list of string to figure out what equals call to use, which I kind of like the notion because, or the two are different anyhow, and they both have their places in the universe, but there's definitely a place that says don't have a V table on the left-hand side for a commutative call because, commutative and left-hand side lookups are directly opposed or something.
So we don't use a V table for the equals.
Yeah, right. Yeah, I get it.
Equals is a function. And so this will first call equals on list. It'll call the function equals defined by list, passing the two lists to it.
Yeah.
But it passes actually a third parameter, which is a type parameter, which is list of string. So then the list then knows to call string equals, not Unicode string equals.
Yes. Right. Yeah.
So it's not just that the lists are compared correctly.
Yeah.
It's that the strings are compared correctly.
Yes. Right. Which means you do have to pass a type parameter along.
That's correct.
Okay, that makes sense.
And that's all done by this.
Which means, well, that is can be trivially turn into a flat, non-virtual call. Inside of list, his equals takes a type parameter. He has to make a virtual call to call either string or Unicode string equals.
No, it doesn't do a virtual call. So equals is it's what we call a funky interface. So it's a function defined by object. So all objects are known to have a function associated with them called equals. But it's associated by the compile time type, not
right.
Not
I'm going to say I'm sorry, indirect call. You have to do some sort of table lookup call.
Yes, that's right.
You can't get a static guy that you can manually inline in the compiler. Like the first level call, list equal equal list 2, the compiler could optimize it immediately to a straight inline call. Because there's only lists equals being called here. Inside of list equals, every time he takes a member and does a string check or equals check on a member, he has to do a virtual call to distinguish strings, plain string from Unicode string. Because that same equals call will be also used on 2 lists of Unicodes.
Right. Well, within the list equal, so.
Yeah, I mean, I could whip out the example I'm talking about, but it's not important. I'm just looking at where you're making performance trade-offs, which they're perfectly fine. Everyone has them.
So this is the list equals function. I'm just pasting the snippet from it.
Oops. Yeah, fine.
I may be pasting, there it is.
Yeah.
Right.
And I would kill all your white space and then it would fit tidily on my screen. And where you call value 1 equal value 2, those have to be done with some sort of table lookup call because.
Well, it's actually that, let me paste in the declaration.
Because value 1 is either a string or it's a uni string, and I need to do something different. Yeah, you have a compile time type list 1, list 2. I get it. Can I compress you vertically so we can fit it all on the screen?
Sure.
You're like, I don't like it this way.
And this is an inferred type of this inferred type from val is compile type dot element. So that's a type variable behind the scenes. That's a type variable behind the scenes. And then this equals is like comparing the lists because we have a compile time type for it, which is an inferred string.
Maybe I'm here. Yeah, right. So you picked up 2 values. They're known at compile time to be typed as, they're either strings or uni-strings in 2 different contexts. Like I can pull up a list of uni-strings and a list of strings and do all the equals, like just clone the code, use uni-strings.
So this gets passed in as list of string by the equals operator.
Yeah, so it's an
argument. And that allows me to use equals here because I know behind the scenes that this is.
Yeah, but which equals you're calling here? You're either calling string equals or you're calling uni-string equal.
It's calling compile type dot element equals.
Yeah, okay.
Which resolves. Yes, it's a table lookup at runtime based on.
That's all I'm asking or saying or whatever. Yeah, fine. Yeah. And actually, I would, do this myself because I'm a glutton for this kind of stuff, but fine. And you're like, oh, I don't like this.
No, we already know you like Thursday.
So if value equals iter not next, you have a comma in your if statements there.
Yes.
Okay. Yeah.
It's a little brother of a semicolon.
Okay, fine.
So think of it almost as a semicolon. So because the first part is a statement, so val is a declaration. So the comma separates one statement from the next within the if. So even though it's a statement, it yields a Boolean because it's using a conditional assignment from the iterator.
Oh God. Wait. Okay, so this is like an and or a short circuit thing. You call iter next. If iter 2 fails, you're done. Else you then go on and do the value
Right.
going value 2. All right, so it's an and clause. Yeah, okay. Yeah, I do this in AA, but I don't use a comma operator there. I demand an and operator. And I don't need the keyword val, which is fine.
Right. Yeah, we introduced keywords val and var just for
Yeah.
because we liked them.
Yeah, no, that's fine.
For
a lot of folks do.
for explicit inference.
Right.
So I've seen them used elsewhere. Peter's smiling, so he must know which language I'm talking about.
I've certainly seen them before.
Yeah.
All right. Well, there was no
Is that
30
the same
shot.
as Kotlin? The var and val?
I think so, yeah.
Oh, probably.
Okay.
I get confused over time about where I saw things first.
Oh, me too. Me too. Yeah.
But val obviously is used in Java, and then and I like the idea that val would be kind of a final and var would be a not final.
Right.
So this in Java speak.
Yeah. Yeah, I think it's fair. That's all good.
One other question I have is, do you have to suffer through type erasure at runtime in XDC?
Absolutely not. We have 0 type erasure.
Yeah. I knew you got that right. I do too, but I don't have any implementation, so I'm lying through my teeth. But yeah, I won't lose those types either. Yeah, the type erasure was always the Java runtime was not prepared for what was required, and so they backfit, and that they were various. You can go read up the evil choices they had to choose between. They picked what they did, but they only had evil choices because it was too late.
Yep, it was still groundbreaking.
Major language with true generics.
Yeah,
major groundbreaking work, and also academics knew that it sucked, it's horrible, you could do better, but only if you rewrote the JVM from scratch. So give it up now. It's not happening. Not quite that bad, but it would have been pretty damn ugly. The runtime would have been completely redone. A bunch of typing things would be redone. Never mind. Erasure, it's water under the bridge. It got us to have generics at all. Geez, that was a win. All right, I'm going to claim victory for the Alliance and shoot Derek's question down, same as I shot down Simon's. And until next time.
All right.
Sorry.
No problem.
Okay.
I'll hopefully figure it out in the meantime.
Been very interesting. Okay, until we meet again.
All right.
Bye, guys.
Yeah.